So the next group of problems are where we have either a zero slope or an undefined slope. And to remember, a horizontal line has a zero slope. That's because if you look at the definition, rise over run, there is no rise, so the numerator is 0. So you always get 0 over any number. It's 0 except 0. 0 over 0 is what we call undefined, or indeterminate. Anyway, that's that, and then a vertical line is the slope is undefined. And that's because we divide by 0, because there's no run, but there's rise. So you have a number divided by 0, and any number except 0 divided by 0 is undefined. So those are the two things you kind of have to remember. So if you're given a point, you only have to write x equals something or y equals something based on the coordinates that are given. So in problem 26, we have through point -4, -3 with a slope equal to 0. So slope equals 0 is a horizontal line. That's y equals something. And the something is always whatever the y coordinate is of the point. So the answer is y equals -2 is the solution. Here's a xy axis. If we plot this point, -4, -2, we get right here. And the only horizontal line that goes through that point is something like that. And notice at any point along this line, no matter what the x value is, the y value is -2. It's basically saying the y value is independent of x. If you have a line that has a diagonal to it, then y is a function of x. Okay, so that's 26. So 29 is the next problem, I think. 29. So it says it's a vertical line, which is an undefined slope. So it says it goes through the point 0.5, comma 0.2, which is fine. We don't have to have whole numbers. It says it's vertical. Vertical. So a vertical line has an undefined slope. So let's draw a vertical line. So that's my vertical line, that's my y-axis, that's my x-axis. So that's a vertical line. And the slope is undefined because the run is 0. So you divide by 0. In this case, it's the exact opposite. The equation is going to be x equals something, because x equals something means that no matter what the y value is, the x value is always some value. And the value is the x coordinate of the pair, the one pair that we're given. In this case, I drew it in the wrong place, so let me just erase that. Actually, no, I did it in the right place. I did it on the right-hand side of the axis. So, let's see, this is equal to 1, and this is equal to 0. This vertical line has an equation x is equal to 0.5. The exact point they're talking about is 0.5 and about 0.2, which should be there. I'm not sure why I drew that dot there, but so 0.5, 0.2, vertical line goes like that. Okay, what's next? 33. So we're in the new group. In this case, they give you 2 points, and you're asked to calculate the equation in the slope-intercept form. So this is the most complicated part, but still not super difficult. So if you're given 2 points, this is the procedure you need to follow. Step number 1, calculate the slope. Step number 2, use this slope from step 1. And one of the 2 points, doesn't matter which one of the 2 points with the point slope form of the linear equation. What that'll do is give you the equation. It won't be solved for y directly. Then you need to solve for y and simplify. And that will put it in the slope-intercept form. Simplify, I can't spell. Solve for y and simplify to put in slope-intercept form. Okay, so given that, and problem 33, we're given 2 points on the graph. So let's just draw a picture of this thing. Draw these 2 points on the graph paper. Think about how this relates to what we're talking about. So we're going to plot these 2 points. 1, 2, 3, 1, 2, 3, 4. So that's 1 point. And the other point is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So let's just identify those. That's 5, 8. This is 3, 4. And there's going to be a line that goes through those points. That's what we're trying to do, is trying to figure out what the equation of that line that goes through those 2 points. So the first thing is we do is we calculate the slope. And we've got 2 points. And you can see the slope is going to be rise over run. It's going to be 1, 2, 3, 4 rise, 2 run. 4 divided by 2 is 2. So the slope answer is going to be 2. But if we don't draw this and we just do the calculations, we use the equation for the slope based on 2 points that go through that are on that line. So all we have to do is go over here and write down x1, y1, x2, y2, and then we plug them in. All we have to do is just look back and forth. Y2 is 8 minus y1, which is 4. Then we divide that by x2, which is 5, minus x1, which is 3. So 8 minus 4 is 4. 5 minus 3 is 2, which can be simplified to 2. So there's my slope, which we said we already knew. So that's my slope. Now we pick one of either of these 2 points. Doesn't matter. We'll do both of them just to show you it doesn't matter. But you really only need to do one. So the point slope form of the linear equation is this. So again, this is the y variable, this is the x variable. This is the y coordinate of 1 point, this is the x coordinate of 1 point. This is the slope. So 2 is equal to m. So now you just go over here, pick one of these 2 points. So if I pick the first point, I'll get y, the variable, minus y1, which is 4. That's equal to the slope, 2, times x, the variable, minus x1, which is 3. So that's the point slope form of the equation. Now, what it says is we simplify this by solving for y. So it's just like we did in chapter 7. The first thing you do is you multiply out any terms that involve parentheses. So you want to get rid of the parentheses. So 2 times x is 2x. 2 times -3 is -6. Then you want to isolate the variable term. Well, in this case, the variable term is y. We're going to leave this over the other side. So it's not exactly the same because we've got 2 variables. But what we want to do is we want to solve for y. So to do that, we need to get this -4 off this side. So you do that by adding 4 to both sides. We always have to do the same thing to both sides. So -4 plus 4 is 0. So that just leaves y. And we get 2x minus 2. 6 minus 4. -6 plus 4 is -2. So that was using the 1 point. So let's pick the other point. The other point was 5, 8. So if we come down to this same point, we'll have y minus 8 is equal to 2 times x minus 5, was it? 5, yeah, okay, 5. So we want to get in this form. This is the slope-intercept form. So again, you multiply out, get rid of the parentheses, 2x minus 10. You add 8 to both sides. That's to get this to go to 0. So I'm solving for y. I get 2x minus 2. So you get the same answer. So it doesn't matter which one we choose. So you only have to do it one way in the future. Okay, next one is 36. All right, 36. Yep. So again, we're given 2 points. Everything's the same. So just go through it. Now, if any of these numbers, if this number is equal to this number, then you'll notice that the x value wouldn't change. If this number was equal to this number, then the y value wouldn't change. Those would be either x equals something or y equals something, but because these are all different, we're going to have an answer. Now this one had whole number slopes. This next one's going to have fractions. So make sure you know how to do fractions and simplify. Okay, so we're going to call this x1, call this y1, call this x2, y2. And again, it doesn't really matter. I could call this x2, y2, and this x1, y1. It doesn't matter. Okay, so first step, calculate the slope. So we use the equation of slope equals y2 minus y1 divided by x2 minus x1. Okay, go up here, very carefully read off what it is. y2 is 1. We subtract y1, which is 5. We divide by x2, which is 8. And we subtract x1, which is -2. So 1 minus 5 is -4. In the denominator we have 8 minus a -2. Well, this is, negative means take the additive inverse of -2. The additive inverse is just the same number, the same distance from 0 on the number line as the original number. So this is -2, which is 2 units to the left of the 0, so the additive inverse is going to be +2. Or you can just think negative times a negative is a positive. So we get -4 divided by 10. Again, we want to look to see whether these have a common factor, which of course they do because they're both even. So if we divide both the numerator and the denominator by 2, we'll get 2 divided by 5. So that is my slope. That's equal to m. So the next step is to use the point-slope form of the linear equation and plug in what we have. So again, it doesn't matter, we can use either one of these. So we have y minus the y coordinate of one of the points, which is +5, so negative, subtract a +5. The slope is -2 2/5. X is the variable. We subtract x1. x1 is -2. So the first thing we'll do is we will make sure we get rid of any double negatives like we have here. So x minus a -2 is the same as +2. Okay, now we're going to get rid of the parentheses. So -2/5 times x is -2/5 x. And -2/5 times 2, you multiply the numerators together. Because this is really 2 over 1. So you get 2 times 2, which is 4. Don't forget your negative sign. So you get -2 times 2, which is 4, over 5. Next, we want to isolate the y variable to get it into slope-intercept form. So we're going to add 5 to both sides. Okay, so this goes to 0. -5 plus 5 is 0. So we have solved for y. The slope part of the x part is simple. What we have here is -4/5 plus 5. So I'm going to do the math later. I'm just going to write everything out. So we just have to do this operation. So why don't we do that separately so we can think about it more seriously. So what do? Well, you've got a fraction that can't be reduced, and you've got a whole number. So you want to convert the whole number to a fraction that involves 5 as a denominator. So we're kind of unsimplifying it, kind of like we unsimplified here when we multiplied things out. So because we need a 5 in the denominator, we need a 5 in the denominator in the way we rewrite 5. And the way you do that is just take the denominator here, which is 5, and you multiply by this number. 5 times 5 is 25. And you can always check by just plugging that in your calculator. 25 divided by 5 is going to be 5. And you get back to where we started. But we have to unsimplify it so that we can combine these two fractions. So because we have a common denominator, we can create a single fraction where the numerator is just these two things added together. -4 plus 25. And -4 plus 25 is 21. Really that's 25 minus 4. You can change the order. That looks easier to do. So we get 21/5. Okay, so that's this constant part. So we can go ahead and replace those two fractions, the fraction and the whole number, with a single improper fraction. We don't want to show it as a mixed number. And did I do something wrong? Or did I write something down wrong? What did I do here? Looks like the right answer. -2. Oh, I missed. Sorry. That's -8. Ah, rats. How many problems have I done so far? Well, that was the problem with 8. So if you used 8 like I did, then you don't have to redo it. But let's just go through here and show how things are different when you use the right number. So that has to be -8. So that's -8. -8 plus 2 is -6. So you get -4 over -6, which is +2/3. So that's where that made that mistake. Okay, so this is 2/3. Correct that, and I'll just erase this whole thing here. 2/3. Okay. So now we're going to multiply this out. Negative 2/3 x, and then you have 2 times 2 is 4, so you get negative 4/3. Then we add 5 to both sides. So again, you get y, solve for y, negative 2/3 x, and we get negative 4/3 plus 5. Yeah, let me just erase all this stuff here. Okay, so negative 4/3 plus 5. We want a fraction involving thirds, so we're going to have negative 4/3 plus so many thirds. Well, that's just going to be this number times that number. 3 times 5 is 15. Again, 15 divided by 3 is 5. That is the same as negative 4 plus 15 divided by 3, which is the same as 15 minus 4 divided by 3, which is 11 divided by 3. That's still not the right answer. What am I doing wrong now? Oh, this is supposed to be positive. Crap. So that's plus, that's plus, that's plus, that's plus, that's plus, and that's plus. So that's 19. 19/3. Did I get it right? That's plus there. So you get y is equal to 2/3 x plus 19/3. Okay, I'm just going to do those two for right now. I'm going to start a new recording.